So coming to our next topic, which is a continuation of earth movements, it is volcanoes and earthquakes. First we will start with the volcanoes. What is a volcano? Generally, how do we have an idea of a volcano? That there is a large mountain through which there is outpouring of, what does come out from this mountain? There is an outpouring of fire. Have you seen a volcano? At least in movies. What comes out of volcano? Some hot molten material which looks like a fire. A river of a fire comes out through the volcano. It flows for a larger distance. Only fire or some other material? Even the smoke comes out from the volcano. Gases comes out from the volcano. It results into the formation of different type of a volcanic material. So from where does this fire, what is a fire? It is not actually a fire, but it is actually a molten rock. Hot rock which has been melted due to extreme heat inside the earth. Is this a molten rock? Now from where does this molten rock comes? Remember your plate tectonics. Remember your seafloor spreading. That is inside the mantle, the rock is in a molten stage, in a molten state. It comes out and it outpours in the form of an volcano. So volcano is a vent. What is a volcano? It is just a vent. It is just an opening on the surface of the earth through which this molten materials, which is known as magma inside the earth, which is known as lava outside the earth, comes out, along with gases, water vapor, steam, and many other materials which are known as fragmentary materials. So what is the term volcano? It is just a opening. But does it occur suddenly? Does it depend on the mood of the earth कि आज चलो volcano करना है, volcano is erupting? No, obviously not. There are some of the processes which go on making a volcano. What are the processes? Is each and every place in the world subjected to volcanic eruption? If the answer is, what is the answer? You will find the answer if you listen again to the plate tectonic theory. So, is there that I am standing here and there can be a sudden volcanic eruption at the place wherever the studio is, maybe in Delhi, maybe in Chennai? Are these sites of volcanic eruption? Do we have history of volcanic eruption in Delhi, Chennai, Mumbai, or in some other place? Does India have a history of a volcanic eruption? Are there any kind of, do you remember any kind of a volcanic eruption, at least in your recent past or till from your birth, which has occurred in mainland India? I am not saying Andaman Nicobar Islands or some other part. Is there any volcanic eruption? Yes or no? You find the answer, you try to remember, your answer will be obviously no. But does India have the history of a volcanic eruption? For example, if you are staying in Delhi, go down, look at the color of a soil. Same thing, you are staying in Lucknow, Allahabad, or anywhere in North India, you go down, look at the color of your soil. What will be the color? Color will be somewhat lighter color material. If you are staying in the Deccan lava plateau region, if you are staying in the region of around Pune, Nasik, Nagpur region, or in this surrounding Maharashtra plateau region, you go down and pick the color of the soil, it will be generally black color soil. You go down to Chennai region, you go down to Bangalore, you go down and pick the color of your soil, it will be reddish soil. So what does this reddish soil say? What does this blackish soil say? Blackish soils say that there has been volcanic eruption in the past. That is the Deccan Plateau region, Maharashtra Plateau region, or Deccan Lava Plateau region of the peninsular India has seen the volcanic eruption. If you remember the plate tectonics lecture, volcanic eruption in the world is associated with the plate boundaries. What kind of a plate boundaries? Is it associated with transform or conservative plate boundary? No. Is it associated with convergent plate boundary, that is coming together of the plates? Yes. What is the kind of a volcanic eruption associated with coming together of the plate? There is an intense folding. One plate goes below the other plate, melts into the mantle, and there is a violent volcanic eruption. Remember, we have written violent volcanic eruption associated with the convergent plate boundaries, resulting into violent volcanic eruption. On the other hand, What is a volcanic eruption associated with divergent plate boundaries or with the sea floor spreading? That is, there is a spreading up of the sea floor resulting into volcano or lava coming out, resulting into fissure kind or silent kind of an eruption. That is a fissure kind of an eruption. So what is a volcano? Volcanoes are just a vent or an opening, but that does not mean that opening will occur at any place. There are some places associated with volcanic eruption because some process has to go inside the earth, inside the mantle, inside the interior of the earth for a volcano to take place. What is the process? There should be divergent or convergent of the plates. Second process is that the molten material, molten rock structure, which is known as magma inside the earth, has to rise upwards. Once it starts rising upwards, it has to bring different kind of, once it reaches the top level of the earth, depending upon what is the kind of a plate boundary or what is the kind of a rock structure there, the kind of a volcanic eruption, that it can be violent volcanic eruption or a silent volcanic eruption. So the rising up of the molten material, the eruption, and after eruption the lava flows for a certain distance, and after flowing it solidifies. Once it solidifies, it turns into rock, which is known as igneous rock. Igneous rock means rock which is formed by fire. So this entire process that is formation of a magma, lava, rising up of this magma or lava, magma from the earth, outpouring of that magma, that is what we call as a lava outside the surface of the earth. The molten rock inside the surface is magma, outside the surface of the earth is lava. Outpouring of this lava and then solidification is known as, these are the processes which goes in the formation of a volcanoes. So here this term is called as volcanicity. So what is a volcano? Volcano is just an opening or a vent. We are not concerned with much more opening. Obviously there will be different kind of opening, but we as students of geography should be concerned with the different processes. So the entire processes which result into formation of volcanic eruption is known as volcanicity. So volcano is just a vent or opening, but this entire broad mechanism which goes in making an volcano erupt is known as volcanicity. What is the difference between volcano and volcanicity? Volcanicity is the entire process which results into formation of an volcano. What are the processes? As I discussed just now, some processes, that is rising up of molten material inside the earth. That is, it is an example of endogenetic or exogenetic process. Inside the earth means endogenetic process. So some processes are endogenetic processes, that is rising up of the magma, while some processes are exogenetic processes. That means blowing up of the volcano, pouring of lava. Lava is outside the earth. Suppose this is a volcanic mountain. This magma will rise from deep inside the earth. After rising, it will pour outside, it will flow outside. Here it will be called as an lava. Inside the earth it is called as an magma. And after flowing for a certain distance, it will solidify, resulting into formation of some kind of landforms. These landforms are known as igneous landforms. If these landforms get solidified and are formed inside the earth, they are known as intrusive landforms, while if they are formed outside the earth, they are known as extrusive landform. So the volcanicity, as I said, has some endogenetic processes as well as some exogenetic process. What is an example of an exogenetic process? That is, the flowing of the lava is an example of an exogenetic process. So first thing is you should know the difference between volcanicity, or volcanism and volcano. Volcano, you remember, again I am repeating, it is just a vent or an opening on the surface of the earth. It is just a vent or opening on the surface of the earth, while the term volcanicity means, it is a broad mechanism or we can say it is a broad term which covers, it is a broad term which is concerned with both endogenetic what will come in endogenetic process? Example, rising up of molten material, gas, gases, vapors, etc. which covers both endogenetic and exogenetic process, and which covers both endogenetic and exogenetic process, that is outpouring of magma as lava, solidification of that lava into rocks, etc. Which solidification of lava into rocks, etc. That this is a broad mechanism which is concerned with the process of endogenetic and exogenetic process, which results into volcanic eruption. Which ultimately results into an volcanic eruption. While volcano is just a vent or an opening on the surface of the earth. So volcano, you can say, is a mechanism. Volcano is an eruption, while volcanicity is a mechanism which results into the formation of an volcano. Now when the volcano comes out, what are the materials which comes out with the volcano? If you have seen in most of the movies or National Geographic Channel, what do you show with the materials with the volcano? You will see that there are sometimes the volcanic eruption is very, very violent. That is, only you can see is the gas, water vapor. There is zero visibility. While sometimes you must be seeing that there is a very fast river of fire which is flowing. Why does it occur? Because it depends upon the kind of a magma or lava. So one of the materials associated with volcanic eruption is magma or lava, the most important material, that is the molten rock. The second important materials associated with the volcanoes are water vapors and gases. That is, lot of water vapor, lot of steam is erupted during an volcanic eruption. It erupts the steam like a chimney, like an industrial chimney. So Lot of water vapor and steam along with some of the dangerous gases are erupted during the volcanic eruption. Some of these gases then react with the atmosphere and result into acid rainfall, result into pollution, addition of pollution. Example, nitrous oxides. Example, sulfur dioxide. It also erupts carbon monoxide. It blocks the sunlight because there is too much of a vapor and gases being erupted, too much of a material. Lastly, not only vapor, not only molten rocks, some of the broken rock fragments, because what is volcano? It is not, if it is a violent kind of a volcanic eruption, then the earth does not open and gives the wave to a volcano. The volcano has to blow the top of the earth. So when it blows the top of the earth, small fragmented of rocks, sometimes large, sometimes medium size, sometimes small fragments of the rocks are thrown up in an volcanic eruption. So during an volcanic eruption, 3 kinds of materials are erupted. So the next topic is materials during the volcanic eruption. Materials erupted during the volcanic eruption. First important material is water vapor and gases. That is water vapor and gases. Now why water vapor and gases? Because the molten rock material, it goes down, oceanic crust, it goes down, results into formation of water vapor, and this water vapor and steam rises upwards due to convectional currents, resulting into eruption of water vapor. Now inside the earth, the molten rocks has number of elements which forms different kinds of compounds. So gases are also erupted, some compounds are also erupted. What are the important constituents? First, 60 to 90% of total gas discharge consists of steam and water vapor. So you have to remember that steam and water vapor constitute around 60% to 90% of gases discharged during the volcanic eruption. Of total gases discharged during the volcanic eruption. Then second, some of the important gases are, you should remember the names of these gases because they have the potential of being asked in the preliminary examination, that what are the different kinds of, these are the important gases which you should know because they can come as an questions in the examination. Second, the gases, important gases which are erupted during volcanic eruption are sulfur dioxide, that is SO2, nitrous oxides, carbon monoxide, carbon dioxide, so these are the important gases which are erupted during the volcanic eruption, steam and water vapor, which is the most important constituent in water vapor and gases category. Then the gases, that is sulfur dioxide, nitrous oxides, carbon monoxide, carbon dioxide. So are these polluting gases? Are these greenhouse gases? Yes. So one of the natural cause of climate change can be volcanic one of the natural cause of climate change or atmospheric heating is the volcanic eruption. Then some of the compounds are erupted such as, but they are compounds such as hydrochloric acid also can be erupted during an volcanic eruption. So one of the first material erupted during volcanic eruption is water vapor and gases, which out of this water vapor and gases, the steam and water vapor constitute around 60 to 90% of gases discharged during an volcanic eruption. The important gases during an volcanic eruption are sulfur dioxide, nitrous oxides, carbon monoxide, carbon dioxide, while some of the compounds such as hydrochloric acid, etc. are also thrown away during the volcanic eruption. The second important material which is erupted during the volcanic eruption is magma and lava. Magma and lava. What is the difference between magma and lava? The difference lies in the location. As I told you, the molten rock material inside the surface of the earth is known as magma. If this molten rock material outside the surface of the earth is known as lava. If this is the earth's surface and if this is a volcano or a vent or opening on the surface of the earth, the molten rock material which lies inside here in the forms of different landforms, such as we will be doing this landforms in the form of sill, dike, batholith, etc. So such molten rock material inside the surface of the earth is known as magma. When it comes out on the surface of the earth and flows outside the surface of the earth, it is known as lava. So the molten rock material inside the surface of the earth and outside the surface of the earth is the difference between magma and lava. Inside the surface and molten rock material outside the surface of the earth. Obviously outside the surface of the earth is the difference between magma and lava. Now, what are the different kinds of magma? Are there some different kinds of magma? Yes, there will be different kinds of magma. See, this is the typical representative diagram of an volcano. But because of your knowledge of plate tectonic theory, you also know that the representative diagram, this just our general idea, layman's idea of a volcano. But you also now know that volcano results into formation of volcanic mountains. But it will also result into the formation of mid-oceanic ridges, that is low mountains. It will also result into the formation of volcanic plateaus, that is Deccan lava plateau. Is this that entire state, which is the state which lies on the Deccan lava plateau region? Mostly the state of Maharashtra, some part of Madhya Pradesh, some part of Karnataka, some part of Gujarat. Is it entirely like a mountain? Is it situated only here? No. It is just a flat plateau. So that means this molten rock material can result into the formation of a mountain, can result into the formation of a plateau. This is because there are two different types of magma or lava. That is we can say there are two different types of magma, and the same magma, when will it come outside the earth, we can say there are two different types of lava. So what are these two different types of magma or lava? The magma or lava is based on, or it is divided into two parts, that is acidic and basic. We will first study the basic magma or the acid, and the second is acidic. Now the difference between these two is, the first difference between the basic and acidic. First we will study the basic. Basic magma or lava is a lava which has low percentage of silica. Because it has low percentage of silica, it is darker in color as it is more dominated by iron. These are hottest of all lavas. And if anything is hot, it is generally fluid. Because it is fluid, it flows for a larger distance. And because it can flow for a larger distance, it gets solidified after flowing for a larger distance. So, it flows for a larger distance before getting solidified. Suppose, for example, if this is the structure, if this is the surface of the earth, and there is an volcanic eruption here from inside the earth, from this vent here, if the magma is basic, it will flow for a larger distance before getting solidified. On the other hand, if the magma is acidic magma does not flow for a larger distance because it has very high viscosity. Why very high viscosity? Because it has very high boiling point. So because it has a very high boiling point, it does not get converted into fluid. So it is very viscous. Viscous means thick. Fluid means thin, water-like. So acidic magma on the other hand is viscous, not fluid. So because it is not fluid, it does not flow for a larger distance. So again, if this is on surface of the earth, and if there is a acidic magma eruption, then it won't flow for a larger distance. It will flow for a very small distance and get solidified. So what will it result into formation of? Subsequent volcanic eruption, it will result into the formation. So remember, it is not flowing for a largest distance, it is flowing for a very small distance and solidifying. So it will result into formation of volcanic mountains, while here it will result into formation of volcanic plateau. Here it will result into formation of volcanic mountain. I am just using the short points for, don't use this in the examination. So one of the basic difference, are you getting why we are studying this, why we are dividing it into two parts? First, basic. Basic has higher percentage, higher fluidity. It has high fluidity. And because obviously it is having high fluidity, and it will have low viscosity. It has lower percentage of silica. It is darker in color. It is darker in color. Because of the presence of iron, blackish color, and aluminium. Because of the presence of iron and aluminium, it flows for a larger distance because of high fluidity. Because of high fluidity, for it flows for a larger distance, or we can say for greater distance. Before solidifying, before solidifying, before solidifying. And because they can flow for a larger distance before solidifying, they are associated with volcanic plateaus, and see, because it has high fluidity, so it can easily pass through the gaps. So it does not have to blow out the top of a mountain. It can easily found a gap on the crust of the earth. Earth's crust is not seal proof, or it is not entirely sealed. It obviously has gaps because of weathering and erosion, so it can easily pass through the gaps like water, and therefore it does not have to blow. And because it does not have to blow, there is such kind of a volcanic eruption is known as fissure eruption or silent kind of an eruption. We will do it later on. You should remember this. It is associated with volcanic plateaus. Example of such kind of a basic rock is, basic lava is basalt. Example is basalt. And how will be the diagram? The diagrams here will be we have already drawn the diagram. The diagram will be structure of the earth. Because of high fluidity, flows for a larger distance before getting solidified. Example is basalt. So what are the general features of basic igneous rock? It has high fluidity, it has low viscosity. What is the percentage of silica? Lower silica percent. What is the color? It is darker in color. Why it is darker in color? Because of the presence of iron. It has higher fluidity, therefore flows for a greater distance. Therefore, because it is flows for a greater distance, it is associated with volcanic plateaus. Example is flood basalt. Example of volcanic plateaus in the world, we will do it. There are numerous examples such as Siberian Plateau, Deccan Lava Plateau, etc. Now, acidic volcanic eruption. or acidic magma or acidic lava. It has, the first point is it has higher percentage of silica. And because it has higher percentage of silica, it is comparatively lighter in color. It is comparatively lighter in color. It has very high melting point. And because it has very high melting point, it is highly viscous and less fluidic. Because it is less fluid, it is solidified. Before flowing for greater distances. Therefore associated with volcanic it is associated with volcanic mountains. Associated with volcanic mountains. As I told you, how will be the diagram for this? The diagram will be it gets solidified before flowing for a larger distance, and therefore it is associated with volcanic mountains. And because it is less fluid, it blows with a greater force, resulting into violent kind of an volcanic eruption. The best example of this is your rock in everyday use is an acidic igneous rock. Example is granite. Example is a granite rock. Now granite is a perfect example of an acidic igneous rock, while basalt, if you want to see the basalt, it is a black color rock which is now found in the western part of Maharashtra, western part of India, known as Deccan Plateau, which is famous for cotton growing region, and this soil is known as black cotton soil, which shows that it is a basic eruption, fissure kind of an eruption, resulting into, because it flowed for a larger distance covering around 5 lakh square kilometers, it is resulted into formation of a plateau. Because it was a basic, there was a dominance of iron in that, and therefore gave it a darker color. Coming to acidic will result into the formation of an volcanic mountains. What are the features? It has higher percentage of silica. Because it has higher percentage, it is lighter in color. It has very high melting point. Because it has a very high melting point, it is highly viscous, means obviously it is less fluid, and therefore it gets solidified before flowing for a larger distance, and therefore associated with mountains, because the magma is solidified before flowing for a larger distance. Example is granite. The first example is basalt here, while यहाँ पे the example is granite. So these are the two different types of magmas or lavas. So this is the second kind of material which is erupted during an volcanic eruption. The first is gases, out of which water vapor is the water vapor and steam forms around 60 to 90%. Second important gases are sulfur dioxide, nitrous oxide, carbon monoxide, carbon dioxide. Then second kind of a material which is thrown out during an volcanic eruption is magma or lava, which we divide into basic and acidic, and these are the features which are associated with basic and acidic magma. And the third are on the third kind of an material which are erupted during an volcanic eruptions are small fragments of the rock. Why? Because when the volcano blows, obviously it does not come out very silently. Even the silent kind of volcano, obviously it will carry some kind of an ash, some kind of a dust. What the dust will, if it is a violent volcanic eruption, the amount of a dust will be far greater, because it will blow away the top of a rock, top of a mountain. When you burst the cracker, the dust blows. When you blow a bomb, the dust blows, the small particles blow, things are reduced into small particles, fragments. Even during a volcanic eruption, which is like a bomb in the nature, it blows away the top of a mountain. It is very powerful. So obviously it will consist of different kind of materials. Such kind of materials are known as fragmental materials. Are known as fragmental materials. So during an volcanic eruption, the fragmental materials are of different kind of fragmental materials, such as volcanic ash, such as volcanic dust, volcanic ash, volcanic bombs, and lapilli. These are the different types of fragmental materials which comes out during the volcanic eruption. They are classified into different types on the basis of size. What are the different types of fragmental materials? These are volcanic ash, volcanic bombs, volcanic dust, volcanic bombs, lapilli, and volcanic ash. On the basis of the size, these are least in size, and these are the largest in size. So the fragmental materials consist of volcanic dust, volcanic ash, lapilli, and volcanic bombs. Volcanic dust are least minute or minimum in size. Volcanic ash is around 2 millimeters in size. This is around the size of a pea. And volcanic bombs are greater than 6 centimeters in size. So these are the different types of volcanic materials which are erupted. What is a pea? Pea means, in Hindi it is known as vatana or chana. So these are the different kind of volcanic materials. Volcanic bombs sometimes can be more than 10 kgs also, more than 100 tons also, which are thrown out during an volcanic eruption. So they consist of, what are this fragmental material? They consist of volcanic dust, volcanic ash, lapilli, rock fragments, so etc. Volcanic bombs. They are made up of fragments of broken rock. Etc. which are thrown during an volcanic eruption, which are thrown out during an volcanic eruption. So these are the different types of materials erupted during the volcano. They are also, these fragmented materials are also known as pyroclastic materials. So what are the different kind of materials erupted during the volcano? What does the volcanic eruption consist of? It consists of water vapor and gases, it consists of magma, and lastly it consists of fragmented or pyroclastic material. This pyroclastic material, which is of least size, less than 2 millimeters, is known as volcanic dust. After that it is known as volcanic ash. After that it is known as lapilli, and the largest it is known as volcanic bombs. These are also called as tephra. This material is also known as tephra. Okay. So these are the different types of volcanic materials. Now why there is a volcanic eruption? Volcanic eruption, as we have now studied, is associated with can be very, very well explained with the theory of plate tectonics. So the next topic is the mechanism of volcanoes.